Hello everyone, welcome to Math Q&A. In this video, we'll be touching on the finite geometric series. The reason why we're calling it finite is because we want to sum geometric values, or we're going to sum values of a geometric series up to a specific point, meaning we're not just summing all of them. And the reason why we're saying that is because a geometric series can be infinite, okay? And the thing is, geometric series, sometimes they actually converge to zero, or they converge to a specific value. Let me rather say they converge to zero. I will explain all those terms in a separate video. But now, for now, let's look at what is important. Now, in the previous video, we have looked at the sum of an arithmetic sequence. Well, and we actually summed the values of an arithmetic sequence. Now we're going to look at a geometric series, which basically is going to be a sum of geometric sequence numbers. An example of that, which I've talked about in the previous video, is something like 2, 4, 8, 16, blah, 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 up to infinity. So at this point, if you look at this, 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. So we can see that a division of the next and of the next value in the previous value always give us a 2. And please note that you're not saying that a division of the first and the previous. You're saying the next divided by the previous. So we start from the second term. 4 divided by 2. 8 divided by 4. Okay. Please take note of that. It's very important. Now, we actually now are more interested not in just finding what term number is which number. We want to find what is the sum of these values up till a specific n. And again, please note that, well, 2 is term number 1, 4 is term number 2, 8 is term number 3, 16 is term number 4. That term number infinity. Now, at this point, we've got really nice, like a nice representation of what you're talking about. Let's go further. Now, if you look at this, if you can see a trend that there's actually a clean geometric series. Now, let's introduce the equation. How do you find the sum of a geometric series? Well, just to get straight to the point, the equation that defines a geometric sum is Sn is equal to a 1 minus r exponent n divided by 1 minus r. Now, here we have a condition. We say where r is not equal to 1. Okay. If they ever ask you the domain of this thing, and they want to find what is the point or what is the value of n where this thing is not defined, that is where this thing is equal to 1. Okay. Meaning the only constraint we have in terms of a geometric series is where r is not equal to 1. Guess why? The reason is that if you look at this equation, you can see that at the bottom of this equation, we have 1 minus r. And if r can be 1, you can see that here we're going to have a 0, which will make this thing to be undefined. And the moment it's undefined, so it doesn't have a value for us. So it means that it doesn't exist. Okay. So let's not go further in that regard. But the reason why we have this is just to make sure this thing is valid. So for any value where r is not equal to 1, this thing is valid. But whenever it's equal to 1, it becomes undefined. Okay, so let's actually just close that. Now, going back to our example, let's go and actually find the equation of that specific example we have there. Let's find the equation or the sum equation of our geometric series above, which is 2, 4, 8, 16. Now, the first thing we're going to do is to describe this equation. Now, this is a sum of n. It's a sum of all the geometric sequence numbers from the first one to a specific n value, which we'll specify here. Meaning if you have n3, it means you're going to sum term number 1, term number 2, and term number 3. And this is exactly what this equation will be doing for us. You see, now we're doing it manually. We know 2 plus 4 plus 8, 8 plus 4 is 12 plus 2 is 14. But then now we actually want to use an equation. What if now we want the sum of terms up till term number 1000? You cannot count that one by one. You need something more, something more concrete, which is this equation right now. Let's describe it. A is the first term, which in our example above is 2. R is the ratio. If you go back to our video of a geometric series, you'll remember that I said R is a ratio. And that ratio is this 2. Is the value you get where you divide the second term by the first term, or let me rather say the next term by the previous term. In this instance, I was talking about the first term because I'm talking about 2 or 4 and 2. But then 8 divided by 4 and 16 divided by 8 also give you the ratio. Okay. So now let's say, okay, fine. Given this description, let's go and find the sum equation of our geometric series.